In this video, we will build a program counter and general purpose registers. Hey guys, welcome back to the channel. So in the last video, I walked you through the design of our 8-bit CPU. So if you haven't checked that video out yet, please go back and watch that video first. In this video, we will build a program counter and general purpose registers for our 8-bit CPU. Before starting this video, I would like to point out a mistake in the last video. I said our address space is 4 bits, but I said our address range is from 0000 to FFFF. That is actually wrong, and our address range is from 0 to F. I meant to say that our address range is 0000 to 1111 in binary. So sorry about that. Before starting this video, I would like to give a disclaimer that I am not an expert in FPGAs or computer architecture. This is just a project which I found fascinating, and I'm attempting to make my own project. So if there are any mistakes, and I'm sure there will be many mistakes in this project, you can just if you know a better solution, you can just point it out in the comments so that both our viewers and I can learn from those mistakes. So without wasting any more time, let's get started with this video. So first we will build our a 4-bit program counter. Let's get started. So we will start with making a folder for our project. In this folder, I'm going to make some subdirectories. One is for our HDL files, for all the VHDL files, and one will be our one directory will contain all our test benches. And we will make one more directory for our simulation project that will be in ModelSim. So these are 3 folders. I recommend you you do the same. And now we will start with the first file. First we will write program counter. So our program counter will be 4-bit wide. It will be able to count from 0 to F. It will have a asynchronous reset. It will be able to load a value, arbitrary value. So it will have a 4-bit wide input bus and 4-bit output bus. It will have a load enable signal and enable count signal. So let us start to write this program counter. I have these libraries written here because I don't seem to remember them ever. So we will make a new entity. We will save this file in our VHDL folder. I will name it pc.vhd. So it will take a clock signal, standard logic, then it will have enable reset signal. Let's name it RST. Standard logic as well. Then it will have enable signal, not end, enable, That will be standard logic as well. It will have load signal, which we will use to load a new value in our counter. It will be standard logic as well. Yes, it will have 4 bits of input. So it will be standard logic vector, 4 bits, so 3 down to 0, and it will have an output value. That will be standard logic vector 3 4 bits, that is 3 down to 0 as well. Now we will define its architecture. I will call it behave. Okay, so let's save this. We will write the first process to reset. Yeah. So since it is asynchronous reset, we will write that logic. If rst not brackets, if then we will need a signal to keep track of count. So signal count, this will be standard logic vector of 8 bits, not 8 but 4 bits. I have written 2 instead of down 2. And its initial value should be 0. So if reset is equal to 1, then count should reset. This is another way of setting all the bits to 0. So else if now our reset is not high, if rising edge of clock then we will check if load signal is active, then we'll have to load the value. If load signal is 1, then we will set count is equal to input, else if enable signal is 1, then uh, yeah, if enable signal is 1, then we will increment our counter. Count is equal, we will assign count is equal to count plus 1, and finally here we will assign our count to our output. So basically this is our I guess this is our program counter logic. Let's compile it and check if we have any errors. So for that we will need ModelSim. We will create a new project in ModelSim. So go to file, new, oops, project. We'll browse to our simulation directory that we created earlier. Simulation. So we will select reference library mappings. We will name our project CPU. So now our project is created. We'll click on add existing file because we have made a file already. And yeah, we will make sure that you select a reference from current location. So we don't want to copy the file in our directory. So just go one level up, HDL, select our file. Okay, and just right click and compile selected. Okay, we have one error. Let's check it out. Near if line number 24. So okay, okay, I forgot to write begin here. Now we have two errors. Line number 26. Oh, and I guess now we must have more errors. Oh, actually compilation successful. So I think our program counter is ready. So next step is to make a test bench. I'll copy this, change PC to PC test bench. Okay, the rest of the things, test bench will not have these, and we will save this in our test bench folder. So our architecture of our test bench, so let's write that architecture behave. I will name it the same behave of program counter test bench is and behave. So we will need a component test bench, not test bench, program counter is. I'll paste this here and component. Begin. Now we will need signals for each pin or port in of our program counter. So let's make those signals first. logic. I'll just copy this and paste a few times. Clock, reset, enable, and load signal. So we need signal for input and output as well. So input signal, standard logic vector of 4 bits, and same for the output signal. Now we will need to make one object of our component, so I will name it PC1. PC port map. So CLK will be mapped to our CLK signal. Similarly for all the other signals, reset to reset signal, enable to enable signal, input to input signal, and output to output signal as well. So now we will need to generate a clock signal. So we will write a process for that. First we will assign 0 to our clock signal initially, and then we will toggle it after some time. So we can write in test bench wait for clock period by 2, and we will just toggle clock value, not clock signal, and then again wait for clock period. Now we need to define this clock period as a constant. Clock period, this will be of type time, and its value, I'm choosing 10 nanoseconds for start. You can change, you can set any whatever time you like. So that is that. Let's just once compile this file so that we know everything is correct up to this point. So in ModelSim, just right click. Yes, so add to project, existing file. Let's browse to our test bench. Compile selected, and we have 2 errors. Okay. Oh, I forgot to map the port load. Okay. So LD will be connected to LD signal. Compile. Compilation is successful so far. So now we will write another process which will simulate some signals for us. Begin and process. So in this process, we will initially set all the signals to low, like enable load signal, reset signal, and then we will, after some time, after some clock cycles, we will um, make enable signal high so that we can see the output incrementing one by one. So let's do that first. So let's set a reset signal to 0, enable signal to 0, and load signal to 0. Then we will wait for some clock cycles, wait for clock period into say 5. Then we will set enable to 1, and we will just write wait, so it waits forever, so our counter will keep incrementing. Well, let's compile this. So it compiled successfully. Now we will generate a waveform and see if our counter actually works. Now right click and add to project, simulation configuration, expand this work. You can see your program counter and program counter test bench here. Click on test bench, give this a name like program counter simulation. You can name it whatever. Save. So double click on this. Okay, have some error. Hey guys, sorry about that. I had to re-download the ModelSim and reinstall the license because my license expired. The license is valid for only 180 days. After that, you have to request it again. So I just did that. Now, just double click on the simulation configuration file, and this window will open. So if we click on our component, which was program counter 1, we can see our all the signals. Uh, so just select all the signals and right click and click on add wave new. So these will be added to a waveform. So if you click run, it will run the configuration for us. And just zoom into the results to see. You can see here our output keeps increasing. So here we only have ran for 100 nanoseconds. So yeah, so you can see the counter output, it is increasing. Now if we want to see some other things like reset or load, we will have to change our test bench and change those signals after some time. So we can try one or two. Let's try resetting. So after 5, we will enable and wait for another 5 cycles, and then we will reset this. We'll wait for clock period, and then we'll again enable one and remove the reset signal and wait for another 5 or whatever, or wait forever. So go to your waveform, not waveform, ModelSim. We'll end this simulation. Uh, yeah, we will recompile our test bench. Sorry, and rerun our simulation. Okay, we'll add these signals to a waveform. Here, we can try running for more time, so we will see more of a result. If we zoom into this, go to the beginning, uh, you can see the reset going high here, and our counter, since it is asynchronous, immediately it resets to 0, and when our reset becomes 0 again, it starts counting again. So this functionality is like our counter is working. If we see the last value f, after f it goes back to 0. So our program counter is working as intended. So this tutorial is getting a bit longer, so I'm going to stop this video here, and we will see general purpose resistors in next video. That's about it for this video. I will put the VHDL file and also test bench file on GitHub. So I will put the link to the GitHub project in the description below. So do check that out. Please try to make your own project, and just take this project for a reference, so that you'll learn something. If you just copy, probably you will end up using this code, and you will not learn anything out of that. Thank you for watching this video. In the next video, we will discuss. We will make general purpose resistors. So if you haven't subscribed to the channel already, please subscribe, and check the bell notification, so that you'll get notified when I post the next video. I will try to post one video every week. So around weekend, I will be posting these videos. So thank you for watching, and subscribe for more videos like this.